In this week's flexible lesson, we'll be just working through a series of worked examples to kind of get your head around the kinds of things you might be asked about arithmetic progressions. I'd recommend, as you go through these, and in fact we would like you as you go through these, before you looked at the worked example for each problem, to actually have a go at doing these problems yourself, and then if you're having trouble, then watch the example. If you can solve the problem with no worries at all, just skip ahead through the explanation to the next problem. But we really would like you, if you want to get the most out of these videos, we'd like you to have a go at all of these problems before you watch me solve them. So the first problem here is a typical arithmetic series problem. It's a fairly straightforward one. It asks us to find the common difference for this arithmetic series that we've got here. And to do this, we are essentially using the recursive definition of an arithmetic sequence. So if you remember, the recursive definition says Tn plus 1 is Tn plus the common difference. Okay? In other words, n plus 1, the next term, is equal to the current term plus whatever that difference is. And if you rearrange this thing and make d the subject, you end up with d is equal to Tn plus 1 minus Tn. So in other words, if I subtract subsequent terms, I can find the common difference. Okay, so if I take one of these terms, let's take this one, 14. If I want to find what d is going to be, it's going to be 14 minus the previous term, which is 16, and my common difference is negative 2, and that makes sense because these things are going down by negative 2 each time. Okay. With this particular problem, we probably didn't need to go through, all this business over here, but it's important to recognize that formula for later on when we look at more difficult problems. The next example is very similar to the last one. We've just introduced some algebraic terms into the sequence. If you haven't already, have a go at this problem before I go through the solution. As before, if we want to find the common difference of this arithmetic series, we need to subtract subsequent terms. So we can pick any two terms. I'm going to go with these guys. I'm going to go 10x minus 7x, and mathematically I should say this is the common difference d that I'm working out here. 10x minus 7x is 3x. That's going to be my common difference. And if you look at the series, 4x plus 3x will give me 7x, plus 3x gives me 10x, and so on going through the series. Here in example number 3, we get a little bit more complicated. And the reason we get more complicated is these terms have surds involved in them. And when you look at this question, it kind of doesn't look like it's going to be an arithmetic sequence, but in fact it is. Okay, so have a go, and remember your surd laws as you try to work through this problem, and then I'll have a go at it. So to solve this question, we need to look at some of these terms and simplify them. So I'm going to do just a little bit of work over on the side. Let's think about the square root of 27. Square root of 27 is like, well, 27 can be written as 9 times 3. So what I've tried to do here is break it into two numbers, two factors where one of them is a square number. 9's a square number. So this is the square root of 9 times the square root of 3, and that's 3 times the square root of 3. If I wanted to consider 12 over here, square root of 12, square root of 12, in the same way, I can break it up into two factors where one of them is a square number. This time it's going to be 4 and 3. And using the same kind of logic, I can go, this is the square root of 4 times the square root of 3. 2 root 3 is going to be that term there. So now if I want to find the common difference, I can take two subsequent terms. I've just worked both of these ones out. Okay, root 27 minus root 12. I've just said that root 27 is the same as 3 root 3. Root 12 is the same as 2 root 3. And the common difference there, 3 root 3 minus 2 root 3 is just root 3. So each step in this series is found by adding the square root of 3 to the previous term.